right, it's always great to go right before lunch. And I will hear stomachs growling, I'm sure. So hopefully we'll be educational and entertaining in this session. We're going to share with you insights about running InfluxDB Cloud, particularly Cloud 1, at scale over the last couple of years. And hopefully this will provide you some insights on maybe two different dimensions. One is just thinking about running and monitoring InfluxDB Enterprise for those of you that are running Enterprise. Can I see a show of hands? Enterprise customers? Okay, handful, all right. And then also, how many people in the audience are doing IoT? Okay, so running or managing a fleet. Okay, so there's sort of two dimensions to the talk, right? One is about the number of Influx Enterprise instances we have running and sort of the things we learned about managing and monitoring ourselves and things we've tried to build into the product and provide back to you as sort of best practices. And then the second is what happens when you try to manage a large number of things or a large collection of things. What are sort of some best practices that we learned just doing that with our own software. So we'll go through this. So first, a little bit of history. We'll look back at the history of Cloud, Cloud 1. We actually originally launched it in May of 2014 on DigitalOcean, and it was simply hosting the open source instance, right? So we just database in the sky, give you an endpoint, you start pouring your data into it, and it was a single tenant deployment. No UI, no capacitor, no nothing. It was pretty bare bones, and we got some feedback on the ways that we can improve that. And so about 2 years later, we migrated everybody over to AWS with the Enterprise Edition. And so all of the plans use the Enterprise Edition, all the features and capabilities, except for fine-grained authorization are exposed and available to the end users. Capacitor was then also made available as an add-on, and it was all hosted on AWS. And then finally, there was additional feedback that we received from the users. And we then offered, as part of the subscription, both access to Chronograph, the UI, and Capacitor as part of the just the basic subscription. We also provided you visibility into the health of the service itself through something called the co-monitoring dashboard. Effectively, you got to see the health statistics of your instance in the same way that our support team was seeing them, so that you could understand the impact of pouring in additional data or additional queries. You could see where you were in terms of things like cardinality, and that would help you make decisions about when you needed to move from one tiered plan to another. And then we also added pay-as-you-go storage. So one of the other feedback points that we got from customers was, hey, you're forcing me to move from plan A to plan B just because I need more storage. Can you just add storage to my existing plan? Why do I need to buy a bunch of compute resources that I don't necessarily need? And so that was added as well back in August of 2017. And then obviously we launched Cloud 2 just a few weeks ago, which is a fully multi-tenanted service, pay-as-you-go all the way, fully elastic, and no credit card required. So Cloud 1 is still available if you want the single dedicated instance in the short term, available in more regions, obviously, than we have Cloud 2. But Cloud 2 is obviously the direction and where we're headed going forward. So in terms of why and what we did, some important aspects come up, right? When you move from development to production, it's important for you to understand what your baselines are, right? How is the database functioning? What is it doing? How much data are you pouring in? How much are you querying out? And what does that look like in terms of the underlying resources that it's utilizing? And without establishing those baselines, it's hard to tell what the health of the system is. And then when changes occur, can you isolate the impact of those changes? And so one of the things that you also want to be able to do is then set up notifications based on the most common issues before they become outages. And then obviously getting folks to investigate those things. And why do you need to do that? Well, first and foremost, when you go from this setup, which you may use for development, single node of Influx, and somebody was asking Chris about the load balancer and why you need a load balancer, you're going to this setup, which is you're exposing the individual data nodes. Typically, a load balancer will sit in front of those data nodes. There are 3 meta nodes. This is the smallest footprint for high availability that you can deploy for Influx Enterprise. So you have 3 redundant meta nodes, and 2 data nodes. That provides that high availability. And obviously, you can scale out from there with additional data nodes if you want to go further. So that's a pretty big change just operationally in terms of understanding the health of both the underlying database from an open source perspective and then moving to enterprise. Now, to go into some of the fun technical details, we've got 2 deployment diagrams here that describe what we've done for Cloud One in terms of setting this up as a service and some of the automation that sits behind it. And I know we've got some MuleSoft customer in the room. Thank you, guys. We actually have this running for them as well in their AWS account so that they can spin up instances of InfluxDB for their customers on an ongoing basis. But it's the same principles apply to both. So in essence, there's some core services that are here. We have a very small Kubernetes cluster that runs something called the cluster manager. It has an internal engineering name, and if you want to buy me a drink later, I will tell you what that is. But otherwise, it's a secret. And it also, there's a cluster backup service. Effectively, we're taking snapshots of the EBS volumes in AWS on an hourly basis. And that's just a scheduled job that runs. And we're taking the EBS volumes across all of the nodes that exist, the data nodes and the meta nodes. We have a monitoring cluster that's obviously set up to, and it's probably no surprise what we use to monitor instances of Influx Enterprise. We're using Influx Enterprise. And so there are Telegraf agents that are deployed on every container and every node to capture all of this information. And I think at last count, we had within our environment about 390 unique clusters that were running. And if you consider there's 6 machines for each of those instances, you can do some quick math, and it's about 2,000 or so servers that we're monitoring on a regular basis. It's all set up as a single tenant subscription. So when you credit card swipe for Cloud One and say you want to buy that instance of that particular plan size, we go and spin up the specific resources associated to that. So that's the 3 meta nodes, 2 data nodes, and the chronograph and capacitor node all get spun up and connected to each other. And obviously you can buy an additional add-on for a larger capacitor size if you want, or you can actually also buy a subscription to Grafana, and we'll host that as well. So that's sort of the underpinnings of all of these things. We're also using Papertrail for log archival. It's important to have an archive of all of the output that's being thrown off of the running services. Our support team uses really 14 days of the high precision and high resolution data off of every one of these nodes to triage issues. So if anything comes up, they have access to 14 days of that high resolution data and 14 days of the high resolution log data. But Papertrail is used to sort of offload that from our running instance. We're also using Key for the software image repository. So we push new instances of the software into Key and then update the Docker container images in a rolling upgrade format as we push those things into production. Now, one of the interesting things that we do in terms of the layout is we actually have the ability to do what we call a shadow clone, which is we can clone an entire instance, put a new version of software on it, and run them side by side. And what is effectively happening is the queries and the writes that are being sent into the database are split in the production environment. So your running instance receives its reads and writes, but there's a shadow of it that's running that also receives the reads and writes. Now, why do we do that? It's all in the production environment, it's all secured, but it's there because we want to do things like operational health checks of new versions. So as before I roll a new version out, I can shadow clone everything in the infrastructure and essentially monitor things like, are there memory leaks? Are there other defects that can be detected before we publish the final version of the software? And that's something as a cloud provider that's super powerful, not only for our customers, but also for community users. And so we try to do all of that testing up front. So the shared services that I mentioned are over on the far right-hand side, Papertrail, obviously our own monitoring setup, and the provisioning service to spin up all of the capabilities in cloud. You notice that there's an application load balancer tier that's sitting in front of this. It's shared across about 90 different clusters that are running. The data nodes are then provisioned, and there are individual containers on each of the nodes. So now if you were talking about sort of 2,000-ish physical nodes, and there's an additional five or so containers that are also being monitored on top. So now we're talking about monitoring roughly 10,000 things. Okay. Each individual clustered instance is secured within its own security group, and the nodes have visibility only to themselves within that security group through the ports that we've sort of specified there. And then the only other thing that we've done is for support purposes, we have SSH access available through a Bastion host. So if support needs to get on those machines for any reason, they can do that. So that's the rough layout of what we have deployed. All right. So obviously we're using Docker. Easy to kind of package these things up, use key to pull those Docker images down, SSH for maintenance purposes. etcd is used as a common rendezvous point for shared meta information between the services. So one of the things about Influx Enterprise is we like to keep the host names and the ports the same. And if you're deploying on AWS, that can be a bit of a challenge as they might change the machine underneath you at some point. And so a combination of etcd for common rendezvous, and we use SkyDNS to provide DNS resolution so that we can keep the host names and ports obviously consistent regardless of what machine gets kind of plugged up underneath us. So very handy to set it up that way. We're also using LogSpout off the Docker container to feed the logs out, Telegraf for metrics and the log events, and then we built a part of the provisioning system called Automatron. It's actually Automatron 3000 is its code name, which essentially monitors the health and availability of the Docker container services that are running on each host. And what it does is it's actually a desired state management system where it says the desired state on that particular host is this configuration tag. And if it matches, then it doesn't do anything. All it does is monitor to make sure that the container is up and running. If it doesn't match, then what it does is goes and pulls the latest configuration tag down and then attempts to restart the containers under that new config tag. So as we do things like push out updates across that large fleet of 390 or so instances, you can imagine that doesn't all happen at once. What we do is we do it in a rolling upgrade fashion through what we call a wave process, which is we reach out to a wave of customers, typically in a particular region or location, and tell them that the maintenance window is open between 4 p.m. and 8 p.m. And this is when we plan to do the upgrade. You shouldn't generally see any downtime. You might see some degradation as the containers stop and restart with the new version. But we generally send that notification out to customers and let them know that that's happening. And then sometimes we receive back, hey, that's right in the middle of some other thing that we're doing, like maybe a demonstration on a main stage or some other activity. And so please don't do it at that time. And we're happy to receive that feedback and coordinate that with you in terms of making those kinds of changes. And that waving process continues in sort of a rolling fashion from we start with a 10% wave of the property, grow to 20%. By the time we get to 50%, we feel like we're in pretty good shape and roll it across the rest of the cluster. Now in terms of, rolling across the rest of Influx Cloud. So in terms of how we're monitoring the instances, and this will be valuable to those of you who are enterprise customers, and we have tried to package all of this information into the documentation, and there's a new documentation set that I'll show you a little bit later where this all resides. But we do use Telegraf, obviously, and from a minimum recommendation perspective, there's 10 plugins that we've activated here that we've described for you. And then we have some optional ones, right? So from a logging perspective, using syslog to capture the log information, swap metrics, internal to gather Telegraf-related stats, and now also the health check Telegraf plugin that was released recently, and obviously Docker if you're deployed in containers. All that information is collected on every individual node and sent to the centralized instance of Influx Enterprise monitoring this entire fleet. Some of the things, and Chris or Daniel or some of the others on the Telegraf team might dive into this more deeply, but we heavily use global config tags. And so if you haven't used these or haven't taken advantage of these, particularly if you're monitoring a fleet of things, I highly recommend you take a look at this. So one of the things we do, obviously, is for each tenant that we have within Influx Cloud, they get a unique cluster ID that's associated with their account that we spin up. And that cluster ID is then used to tag the entire set of metrics that are fed back to us. And I'll show you how we use that a little bit later. We also have an environment tag. It tells us whether we're in a production environment or a test environment. And then the other sort of global tags are things like, how big a payload do we want to send from the Telegraf agent and on what frequency. And you can see here, I think we're at a 10-second interval. Now, gathering 10-second interval, again, 14 days, that's a lot of metrics. But at least from our operational experience of running InfluxCloud now for 3+ years, 14 days is sufficient for us to triage literally any issue. Why is that? Because we typically get 2 compaction cycles, right? So if you're doing, let's say, a typical enterprise cluster with replication factor 2 and a duration, normal shard durations that are not infinite, typically we'll do weekly shards, and so you'll get 2 compaction events available in all the metrics that you see, in addition to whatever your ingest and your query rates look like. After the 2 weeks, what do we do with the data? We actually downsample it to 5-minute summaries, and then we're keeping that data currently forever. It's sufficiently small at this point after, and we are obviously selective in terms of we're not downsampling everything. We downsample all the sort of interesting metrics for us, things like cardinality for sure, CPU utilization over time, memory utilization over time, those sorts of things. But not every metric is captured and stored. And once we downsample that and keep it, then what it's telling us is trend information about how customers are on a journey. Many folks are using Influx Enterprise and reach what I would call a steady state in terms of the amount of data that they're sending in, the number of queries that they run, because there's dashboards and these sorts of things. And they essentially reach this sort of flatline state where their cardinality is relatively consistent, their usage is relatively consistent, and it's because the use case that they're solving for is done. There are other customers that are on a different journey, right? So they're increasing the number of devices that they are monitoring over a period of time. For example, there's a customer in Europe that has a business that's focused on thermostats. That technology is generally used starting in September and then stops being used about April, right? And so literally you can watch the usage statistics both in terms of the information being reported in by every individual sensor as well as the number of queries that are coming from the users interested in their data, right? It's totally seasonal. Plus, summertime, they actually sell a lot of those things. People are thinking about the upcoming fall and winter, and so from year over year, you can actually watch the incremental number of devices roll out across the entire property just by looking at the utilization of metrics and the metrics that are landing. So very interesting stats that we have. Is anybody using global tags in the room, taking advantage of this yet? Okay, a couple. For those that aren't, I definitely recommend taking a look at this, and you can set those obviously through environment variables like we're doing here to make the automated usage and take advantage of that much more simple. Okay, so yeah, so global tags at the top, we're using a globally unique identifier for things like the cluster ID, and we do it on every node, so they're all consistent and consistently report those stats. And then the agent configurations at the bottom, so that speed of observability, you can tune that. For InfluxCloud 2, particularly in the free tier, I've dialed this down. I'm actually monitoring my laptop and a computer that my son and I built. One of the most expensive components in that machine happens to be the CPU. I didn't know whether we installed it correctly. And so one of the things I ended up doing was I turned on the sensors plugin in Influx. That gives me the heat, the temperature values that are coming off of that particular CPU. And so I'm watching that. And then as a funny side effect, I can also find out whether my son is doing his homework, because when he starts gaming after school, I get an alert because the temperature tends to go up on that CPU. So I'm pretty sure that's GDPR compliant as well, because I'm not sure it's him, but I certainly know when that temperature goes up. So I now have a child monitoring service available in the free tier in InfluxCloud. All right, that's working well. So other things that we do on Cloud 1, input configuration, obviously we're using the CPU, memstat, netstat, system, disk IO, sort of common stuff that we get. Another super valuable feature of Telegraf is this field pass and name pass, and I don't know if anybody's tapped into those, but it's the specific things that you want to gather from a device, or in this case, I only want these 4 fields that are coming off of the CPU stats. I can actually block them from being sent. And so you can take advantage and dial that collection down if you need to. Inputs on the data nodes specifically. So obviously I'm exposing and gathering information off of the debug vars endpoint of InfluxDB. So if you haven't looked at that, again, this is fully documented of what is being output through that debug vars endpoint, but it is essentially a whole collection of metrics. In InfluxDB2, we adopted the Prometheus exposition format, and so that changes to /metrics. And you don't have to have a specific input plugin for that. You can actually just use the Prometheus plugin in Telegraf and point it at that endpoint, and it'll scrape and pull that data right out. We also are taking advantage of the ping endpoint that's available on the data nodes, and we use that for availability checks, right? And we've actually deployed something as a third-party metrics instance of Telegraf to come through the front door to observe what the health is looking like from the end user's perspective. From a disk perspective, we're checking on some of the most popular areas where we land data. Obviously the data directory, the wall directory, the write-ahead log, hinted handoff queue to see if there's anything building up. And I'm also checking the root directory. That seems important. Sometimes operating system updates or other things that a support person might do will show up in the root directory and can chew up disk space. So important to kind of capture those 4 things. All right, so we talked through that. Next, metanodes. So again, metanode also exposes a ping endpoint, but on a different port than the data nodes. We're also looking at metadata for the metanodes themselves show up as a snapshot in the snapshot directory. And so we're looking at that directory to make sure that we understand what's going on and whether or not there's an issue. So sometimes we saw a defect at one point where snapshots were sort of building up in that directory and not being purged. So that's something to look at. And again, from a disk perspective, we're looking at the meta directory and root directory on those volumes. Now, metanodes in enterprise are typically not used that heavily, meaning they contain some interesting state information, but they're not super active. The only things they're really used for is coordinating the creation of shards, holding on to user information about authorization, all of that sort of stuff. And they're also then used for backup. And so typically we're running all of our metanodes on a T2 micro, which is a fairly small machine, mostly because we're using all of the backup stuff is being done offline using the EBS volume snapshots that AWS is providing us. So we're not using the direct backup mechanism that's available in the product directly. Okay, so from an output perspective, if that's the stuff we're capturing off the data nodes and the metanodes, then where do we send it? We put in the URL of the target influx monitoring instance that we have within the environment. We throw it into the Telegraf directory, autogen, timeout, so on and so forth, and we're using the content encoding. So if you didn't know this was available, you can actually zip the contents of your payload before you send it off to the server. As it's all mostly text-based information, this provides some compression, which is super helpful. Yeah, pretty straightforward in terms of setting that part up. Again, somebody asked about the load balancer. You shouldn't point it at an individual data node. You should point it at the load balancer that sits in front of your data nodes and allow that to then distribute the load across those data nodes. And also, obviously, if you lose a data node for any reason, it'll direct those metrics to one of the data nodes that's still up and available. Gathering logs. How many people are gathering logs with Influx now? Dylan, you're amazing. By the way, if those that didn't see Dylan's talk about GDPR compliance and the use case that he did last year, I definitely recommend you watching on YouTube. It's both educational and entertaining at the same time. But logging is something that we do. It's metrics and events. Log information is an event. Every log line is an event. Okay? I realize that sometimes the log data can be quite expansive, and while we're recommending that you use SSD for high performance of the database, The question you want to ask yourself is, why am I using those logs and in what context? And really dial down the retention policy so that you don't burn all your SSD storing those logs, okay? So for me, I look at them, I want to look at that 14 days worth of logs in the context that I'm using the metrics, and then I flush them after that because they're all going to paper trail. Now, we're talking about a feature and capability, probably available in 2020, called tiered data storage. When we do that, your option to store logs in Influx for a longer period of time at a more cost-effective rate will absolutely become possible. So gathering logs, definitely take advantage of this. Again, in that short-term window, use the syslog input. You can tap into that, and then you can put all of the log information. You can see here, I have one output that drops anything that starts with syslog. But I have a second Influx output that is going to the exact same location, but I've created a specific location within the Telegraf database called syslog, and I'd land all of the information there, okay? So this is a sort of a tricky way to configure two output plugins. It's not dual write, it's actually sending the information to the same InfluxDB monitoring instance, but the top one is sending the metrics, and the bottom one is setting the log details. Does that make sense? Obviously, the second one is also sending it into a retention policy, which is 14 days by default, and purges that out somewhat aggressively. And the slides will be available too, so don't feel like you have to take pictures unless you really want to take action on it later this afternoon. All right. So yeah, using that name pass and name drop is super valuable when you want to direct the metrics to different locations within the same instance of Influx. I'm actually using the same pattern on my laptop when I'm doing an interesting demo where I'm capturing some information on my laptop on a local open source instance of Influx, and then in some other metrics I'm sending onto the cloud. So a little bit of a dual write scenario, but then also a little bit of a, taking advantage of some of these capabilities to really shape where things go, why they go there, based on a single instance of Telegraf. All right, so now let's talk about, we're gathering all the data. I've described, all the cool stuff that we're doing behind the scenes to set up all this Influx Cloud. So now what? Well, I need some dashboards, right? So we built over time a whole series of dashboards. For every instance of Influx Cloud that's running, obviously you get a unique cluster ID, and I can tell that this is really easy to see here, but there's essentially a drop list that has the cluster ID available. And so what you do is you hit the drop list, you select the cluster that you want to look at, and then all of the metrics refresh, obviously, as you would expect, to show you what's running. And maybe not surprising or not surprising, we also have it available in Grafana to see how that works and compare and contrast features and capabilities of each of those things. And obviously, we'd like to be familiar with the best practices in terms of building these things for Grafana as well. So we built those things, and then we watch them, obviously. Support team watches them 24/7, and then we want to know, well, what are the most common metrics that we want to take a look at? How many people have run out of disk space in the last 60 days on a node? Okay, I know you're very shy, but thank you for some of you being honest. One of the most common things that still happens in the 21st century is hosts running out of disk space. I realize it is embarrassing. It's as embarrassing for you as it is for us, since we provide these tools and capabilities to help you avoid that problem. But it does happen, right? And so one of the things we're looking at is disk usage. For every plan in Influx Cloud on Cloud 1, you get a certain amount of disk that's allocated for and dedicated for your use. Sometimes you'll roll out a new use case, and that use case will start consuming a mass amount of disk space. And you may not realize that, but we do. And typically that's when you may receive a email from our support team suggesting that it's time to buy more storage. And that doesn't happen at the end of a quarter, just to be clear. That is not a revenue producing opportunity for us. We are looking at that very carefully relative to your plan size, and then identifying when you've reached that point, because sometimes you're not looking at your co-monitoring dashboard either. And in some cases, it's a mistake. Sometimes you're feeding in more data than you expected. Maybe you want to dial down your retention policies. All that's available for you to do, but looking at disk usage is certainly one of those things. Hinted handoff queue is another. For those that are not familiar with enterprise, hinted handoff queue is essentially the mechanism that's in place to ensure eventual consistency. So what that means is if a node is down for any reason, the other node will queue up the points that need to be sent and written to that target node when it comes back online. And of course, the ever-present dead man, I'm not receiving any metrics, and so what should I look at? We've been continuing to add additional things over time. Another one that we're watching is containers per host. So we're expecting that 4, 5, or 6 containers are running on those hosts, as I've showed you in the previous picture. That's another thing to look at. Sometimes one container may have problem for a variety of reasons, and if you only see sort of 3 containers running, that's very suspect. You should probably go and look and see what's happening. So to dive into this a little bit further, and again, you don't have to take pictures. This is available in the documentation. This is a batch task that we created for the disk check. So we want to look at disk usage. We want to look at them across those different directories that we mentioned, the data directory, the write-ahead log, hinted handoff, and of course, a good old root, and the frequency at which we kind of do those checks, right? And we're grouping by the host, the role, the environment, and the device that it's running on. And so that's the query that's run from a batch perspective. And then the alert side of it looks like this. When it reaches 85% utilized, we send out a warning. So the support team will actually receive that warning, and if it reaches 95, then it moves to critical. We actually page already on the warning side because I don't want us to be in a situation where we only have 5% disk space available. And so anyway, it also goes to Slack. And so there's a running log of how frequently this is occurring. But the very simple setup to kind of do that. And it tells us obviously which clusters this is on, and then we'll take action. In terms of hinted handoff queue, it's similar. But in this case, I'm using the stats that are emitted from InfluxDB. Here I'm selecting the max queue bytes off of a particular host, which happens to be the data nodes. And then I'm grouping it by the host and cluster ID. Now, an interesting thing about hinted handoff queue is it doesn't necessarily mean the node is down or completely unavailable or unreachable. Sometimes if you're pouring in tons and tons and tons of metrics, the communication between the nodes just may be slower than normal. And the slower than normal means the cluster is busy. Maybe you have somebody running an ad hoc query that's extremely large, that's consuming resources, that's preventing additional points from being written in. The eventual consistency mechanisms that are available within the database are there to provide this sort of self-healing. And so at one point, we had hinted handoff queue warnings that were set extraordinarily low. And so for some clusters that were extraordinarily busy, we were getting pinged and paged on a fairly regular basis. And what we found over time is we've dialed in exactly when we want to be notified. And in this case, it's about 1/3 of the default size of the hinted handoff queue, which is 3.5 gigabytes. So I don't really want to know about it if it's under that threshold, but if it's over or at or over, now I want to be told. That's something where we may want to go have a look and see how long that's been occurring. If it's an individual spike, that's one thing. If it's something that's been building over a period of time, clearly something's wrong and we need to go have a look. We have at least one customer sending us 10 gigabytes of data every 90 minutes. That's a lot. And so, if you think about that, I'm getting paged when it reaches 3.5 gig, and that's about 30 minutes in. And I have 60 minutes to get to, if it's every hour, whatever, 15, 30, 23 minutes, whatever it is, like I have a very limited amount of time to get back to a computer, particularly if it's on a weekend or something, right, to go and do that investigation. So obviously for some customers, you may want to dial those things down to provide you more time. But that's sort of where we landed. So we've got warning and critical, and then you see in this case, the Slack and PagerDuty alert endpoints are listed down there. Okay, so we've captured all that information for you, and we put it in this blue box at the top, which says literally start here, but everybody skips past and goes to the individual components that they're interested in. So my recommendation is if you're really looking for more information about the operational monitoring, the characteristics, and how to take advantage of all the information that's thrown off of InfluxDB, definitely click on the thing that says start here in the middle of the page, and it'll explain all of that, all of the metrics, what they're for, and how to take advantage of them. And there should be examples there also of the TICKscripts that we just went through. And then there are also pre-built dashboards that we provided for Chronograph that you can download and install immediately, both for open source, for enterprise. They'll work off of the use of the Telegraf collection for the stats, or it'll also work off of _internal, which is the default location where those stats land. All right, so let's look at some common troubleshooting scenarios, and I'm going to look at them visually. So one of the things we see sometimes is something called an loop. So this is an out-of-memory loop. It looks like this. So this is a view of all of the nodes within the cluster. The ones towards the bottom in that 40 to 30% range that look flat, those are the meta nodes memory utilization. And the two that are sort of oscillating above that are the data nodes. And so this is a situation where the amount of memory that the data node requires is exceeding what's available. And so what happens is it crashes, and then Automatron 3000 restarts it, and then it starts back up, and then tries to recover, and then it does a thing for a while, and then it crashes again. And so this is a condition that can happen again if your system needs more resources. And so if you're in a cloud environment or a virtualized environment of some kind, this is a signal that you need to provide more memory resources to that node, either permanently or on an on-demand basis. And so for us, from a support perspective, if we see something like this happen or we get paged for something like this happening, we can trigger a cluster resize. And again, if you're a customer of Cloud One, you would get a notification from the support team saying, hey, we've issued a temporary resize, and we'd like to talk to you about what's going on with your system, and maybe you made some changes on your side. Let's see what happens, and then so we'll engage on that front. Second, and this is a more exciting one, particularly on new deployments, runaway series cardinality. Somebody up front was asking about this a little bit earlier in Chris's talk. It'll look like this. In this case, it's maybe hard to see black with the lights, but obviously along the x-axis is the time dimension. In this case, this particular customer was growing their cardinality from 6 million to 8 million over the course of 5 days. We often see this happening within 5 hours when there is a defect. So sometimes a Telegraf configuration will get deployed and you're not exactly sure about why it is. It's misconfigured, but you'll see cardinality just spike up, right? So one of those things to think about when you're doing the monitoring and what you want to get alerted on is, do you look at the cardinality that's landing, and do you have an anticipation of what a change you're about to deploy and impact is going to have on your system? Other things to look at, things to think about, workload type. What workload type are you? Read heavy, write heavy, or mixed? Some folks are super heavy on the right side, where they're landing tons and tons of data, but the amount of dashboards they have is one. There's one dashboard, it's in the office, our CEO looks at it, that's it. And some are mixed, okay? But establishing those baselines for what your workload looks like will also help you understand when you make a change, what is now normal. Is it normal? Is it not normal? What did it look like before? And then reestablishing those baselines over time to help determine when it's actually time to scale up. You will run out of resources using Influx at some point. We love memory, for sure, and CPU is a second thing, obviously, to look at. Network bandwidth, IOPS, these are all resources that you will run out of as you are experiencing the value of the database and pouring more and more data into it. And so understanding when you're reaching those limits and not expecting that it's just an infinitely scalable thing, if you want that, go to Cloud 2. We're ready to handle your workload there. IOPS and disk throughput, understanding the capabilities by plan size. So you will run out, and the plan size is there. We have guidelines on the website that have tried to capture this, and I kind of used a Star Trek metaphor where I gave you the green zone. We know that the clusters will function correctly under that workload description. I've left me some Scotty buffer room, the yellow alert and red alert above that, in case you have a burst capacity, but we know for sure the guidelines that are on the website will work by extracting them from all the clusters that we had available over the last 3 years. And then log analysis. I wrote a blog last year. Some may have seen it or not seen it. It's called Metrics First. If you haven't seen it, definitely recommend go look at it. This is the 21st century. If you should be using log files as your primary source of monitoring systems, I think you're doing it wrong. You have KPIs, you have business level objectives that you're trying to meet. Instrument your systems, gather those metrics. Logs are valuable, don't get me wrong, but they're contextual information that help you triage a particular problem. They are not the problem. So doing a needle in a haystack search for log information to help you triage a problem seems very 20-ish century. So definitely check on those things. What do we miss? Influx is not perfect, for sure. We make mistakes. We have our own challenges. We have defects. We fix them. First thing, head for the balcony. What I mean by this is, we get caught up in individual pages and individual instances, but once we got to a fleet size of more than, I would say, 100 instances, I got pulled into lots of different directions. I was working with customers. I was working with marketing, enabling the field. And the question was, I needed a view of the entire property of cloud, not on an instance-by-instance basis, but as a fleet. I wanted to know where the problematic instances were. I needed a summary dashboard that allowed me to look at all the metrics across the entire property and help me pinpoint just the areas that I needed to provide direction to the support team on. And so yes, the individual dashboards are important because you want to go to that level, but I headed for the balcony and then I built new dashboards that surveyed the entire property and landscape and gave me that snapshot and view. What's the experience of the customer, right? We needed to be able to monitor from the front door as well as from the back office. And so we did set up real user monitoring through the load balancers for AWS and all the way to the individual data nodes. And also we did some integration with our subscription management system to understand things like how much disk were you allocated. One of the things that we're able to do now with Flux as we're changing the monitoring system from InfluxDB 1 to InfluxDB 2 is I'm actually able to use Flux to join the data that we have in a Postgres database around our subscription management with our metrics that are available in the time series database to provide an integrated view of all of that information. Because I've obviously provisioned disk space. That's not necessarily what you purchased, right? You're purchased and running a particular set of disk, and if you add and buy more disk space, how do I tell the metric system that now your threshold is higher? So correlating those two pieces of information allow me to tune those things much more easily by combining, again, SQL data with my time series data. Cert expiration, anybody run into this ever? Some smiles, yes, thank you. We did it too. Telegraf will monitor your certs. We forgot, we didn't put that in, so our cert expired, and then it was like, hey, what's going on? This does happen. Don't forget about that. Like, we were so caught up in the machines and the influx running and all the things and the load balancer, and then it was like, oh, we forgot to monitor the cert. Oops. And then our e-com system. Right? So we have a front door where people can sign up and register for trials and all of those sorts of things. And that link, we had an SRE reset the password on the subscription management system on the back end, and that crashed the e-com system. So monitoring the health and availability of everything, not just the service that you're running, but all the components, integrated components end to end. We've obviously built those things out over time. All right, recap. Metrics, gather those logs for context. Go read the metrics first blog and see if that's what you're doing. Definitely explore using Influx for logging information as well. Once you gather that information, definitely visualize it, build your monitoring. Your monitoring is never done. You're going to find new use cases, new capabilities, then you can build new alerts as you go to make sure that you're catching those things over time. You are going to iterate. You're never going to get it right the first time. That's okay. We're all very smart people in the room, but you will need to learn things over time. Just add to it. It's an expected behavior. And lastly, definitely tap into the community site. Our DevRel team does attempt to answer all of your questions. There are a lot of them, so we appreciate your patience as we work through them. And then go to the docs. Docs are updating on a regular basis. The docs are not static. I have a team that's contributing and filling in areas, obviously, where we've had gaps before. And don't think of the docs as a fire and forget. Like, if you've been there once and it wasn't there, if you want to file an issue in the docs repo, the docs are open source as well. Let us know. We'll fill in that content and improve those things over time. And that, I think, is all.
Questions before we go to lunch?
Yes, hungry people. Please go eat
Well,
lunch.
Tim is around all afternoon, and you're more than welcome to snatch him up and ask your questions face to face. All right, so we'll see you.